All right. So now I'm going to do three examples. Okay, three examples of parametric equations. We're going to plot them, and then we're going to indicate the direction of motion. Okay, and then we're going to actually find the Cartesian equation by eliminating t. Okay, and see if that kind of aligns with our drawing. So we're going to go back to our nuts and bolts and make ourselves a table to put in some points. Okay, so I have t, I have x, I have y. Okay, our t is going between 0 and 5, so I'm going to do 0, 1, 2, 3, 4, 5. I'm going to look at my x coordinates first. So 1 plus 0, so this is equal to 1 plus root t. So that's 1, that's 2. This is 1 plus root 2, which is about, so root square root of 2 is about 1.4, so this is about 2.4. This is 1 plus the square root of 3, which isn't getting a lot better. I've got about 2.73. 1 plus the square root of 4, I got that one, that's 3. And this is 1 plus the square root of 5, which is about 3.24. Great. Y, going to fill that in. This is t squared minus 4t. So I've got 0 minus 0. I have 0. 1 minus 8. Nope. Yep, 1 minus 4. I can do that. 1 is, see, it gets a little confusing, right? I'm staring at my x coordinates. You need to be really clear. Like, I would cover it up if I could for you. I don't know if you can see me. I'm like covering up this in order to kind of not get confused. So I'm doing 1 minus 4 times 1 is negative 3. 2 squared is 4 minus 4 times 2 is negative 4. And then I get negative 3, and then I get 0, and then I get 5. Okay? And I am going to just kind of write the points in here. I'm going to go 1, 0, and then I'll go 2, negative 3, and then I have 2.4, negative 4. And let me start tracing these. My x coordinates, those are all positive, so let's make my, I'm going to go 1, 2, 3, 4. That should be enough. And my y coordinates go up as high as 5 and as low as negative 3. So 2 minus, no, 1 minus, and then I've got 2.73 negative 3. I'm as low as negative 4, excuse me. Gotta be careful. And then I've got 3, 0. I do not want, I'm going to try to put the colors in. There's not so many advantages to doing things in remote, but let's take advantage of those we can. Okay, so 1, 0. That is this point. All right, that is the point t equals 0. Okay. Then we get the screen 2 comma negative 3. So 1, 2, 3, negative 3. So that's this point. This is t equals 1. Okay. Then we get 2.4 negative 4. So let's make that about here. And then we get this black point, 2.73 negative 3. So kind of about there. So this is t equals 3. This one is t equals 2. Then we get the point 3, 0 at t equals 4. That's coming from here. And then we get this bigger point, if I can write it, 1, 2, 3, 4, 5. We get the point 3.24, so about here. Okay, this is t equals 5, and I want to fill in my curve, tracing it in a particular way, and indicating the direction of motion like this. Okay. So that's my curve. I have plotted my points and I have indicated the direction in which the curve is traced. Okay, I have my initial point, I have my terminal point, I'm on a closed interval, but now I'm going to find the Cartesian equation by eliminating t. So let's do so. Okay, so I have x is equal to 1 plus root t, and I have y is equal to t squared minus 4t. All right, so I'm going to x minus 1 is equal to the square root of t, and I'm going to do x minus 1 all squared is equal to t. I'm going to take this and plug it into this formula. Now I got y is equal to, well, x minus 1 all squared, minus 4 times x minus 1 all squared. I can factor this out a little bit. I've got an x minus 1 squared that I can factor out of both of these. So I've got x minus 1 squared, and I'm left with an x minus 1 squared minus 4. I've got y is equal to x minus 1 squared. What does this become? This becomes x squared minus 2x plus 1 minus 4. Y is equal to x minus 1 squared, x squared minus 2x minus 3. Adds to give negative 2, multiplies to give negative 3. So that is x minus 3 times x plus 1. Okay. And indeed, we do see our roots existing. So the root that corresponds to x minus 1 is happening here at this point, and then the one that corresponds to x equals, the factor x minus 3 is there. All right. We could, use this information to say, well, we got ourselves a root at negative 1, 1, 2, 3. This is a double root here. It looks vaguely like this, but that is just a curve. What we've drawn above is a parametric curve, okay, a curve traced in a particular way. Let's jump down to the next one. Here we have another curve. I'm going to, again, make a table. I have t. I have x is equal to t squared minus 2, and I have y is equal to 5 minus 2t. Okay. My interval is going from negative 3 up to 4. So these are my test points to help me fill in my details. All right. T squared minus 2, so that's 9 minus 2 is 7. 4 minus 2 is 2. 1 minus 2 is negative 1, negative 2, and then I get negative 1, 2, 7, and 16 minus 2 is 14. Great. My y-coordinates, I'm dealing with 5 plus 6, that is 11, 9, 7, 5, 3, positive 1, negative 1. Am I all squished? I'm all squished in a weird way. So this is 3, 1, negative 1, negative 3. Okay. Drawing my parabola, I have to go, my y's have to go as high as 11. Okay, so let me erase this. So negative 1, negative 3. 1, 2, 3, 4, 5. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And my x's go out to 14 and as low as negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh. And I am running into my dead spot. Okay. And I am going to simply start at 7, 11. So this 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 7, 11, way up here. So that is my t equals -3. And then I go over to 2 and 9. So this is t equals -2. And then I got -1 and 7. That's way up here. So this is t equals -1. 0 is -2 and 5. And then I am plotting the point 1, -1. No, -1, 3. I can do this. There's t equals 1. And then I get the point 2, 1. T equals 2. And then I get over 7 up -1. And I get 14 and -3. That's 4. And so my curve is again, well, it's supposed to be looking like a sideways parabola. My scale's a little wonky, okay? And I put in my arrows to indicate that. Okay, is this a sideways parabola? A little more involved than the first one we saw? Absolutely. Let's show it. Y is equal to 5 minus 2t. So we can do y minus 5 is equal to -2t. So we get 5 minus y over 2 is equal to t. Use that in my parametric equation for t. So I get x is equal to 5 minus y over 2 squared minus t. I get x is equal to 1/4 5 minus y squared minus 2. And yeah, indeed, we do have ourselves a sideways parabola. Parabola opening sideways. And my direction of motion has been indicated using these arrows. Okay? I should probably draw some more. I can draw more. All right, that's my direction of travel. Let's do one last one. X is equal to e to the t. Y is equal to t plus 1. Sure. So we'll start a little blindly, I guess. We don't have an interval. It hasn't been given to us explicitly. So our interval is just going to be the real numbers. So I have t, x, and y. I don't have an interval, so unlike before, where it was sort of like, I'm just going to like evenly space some values, like these tables are meant to kind of help. We don't have to worry about getting every point. Getting every point is impossible because these are continuous. But let's use some spot points to help ourselves out. So we want something quite negative. Let's figure out what's happening around 0. Let's make something quite large. So let's do -10, -2, 0, half, 2, and 10. Okay, these points are meant to be illustrative. They may or may not be perfect, but we're trying to get an idea about what this thing looks like. So I'm staring at e to the 2t. So that's e to something really small. So it's e to the -20. So that's something very small. This is approaching 0. Okay, from the right, it's a positive number. This is e to the -4. E to the 0, well, that's just 1. E to the 1/2, e to the 2 times 1/2 is e to the 1. That's just e to the 1, which is e, which is 2.718. E to the 4, great. This is e to the 20, which is kind of starting to go off towards infinity, which is nice. Okay, my y coordinates, those are a little more well-behaved. So what do I have? I have -9, -1, 1, 3 halves, 3, and 11. So let's organize ourselves. My y coordinates are like -9, going off to like 11. So I'm going to just give myself a -9 here and try to maybe use another color. It's like this is kind of like really close to the x-axis. This is t equals -10. I'm going to give myself e to the -4. That's, again, like it's pretty close to the y-axis. It's at y equals -1, so let's go -1 here. So I'm going to put this here, t equals -2. 1, 1. So here's 1, here's 1. There we go. So this is t equals 0. T equals 1/2, so there's 1, 2, there's 3. So we're getting bigger. And this is 3/2, so that's going to be not that much bigger. This is t equals 1/2. Okay. And you kind of see this like logarithmic shape developing, hopefully. E to the 4th, we're getting bigger. And we're just kind of drawing it out like this. Okay. Eliminating our variable to show what's going on here. Absolutely. We're getting our logarithmic shape. Okay. X is equal to e to the 2t. Well, what does that tell us? Take the logarithm of both sides. Ln of x is equal to the ln of e to the 2t, which tells us that ln of x is equal to 2t, which tells us that t is equal to 1/2 ln of x. And my y, well, that is equal to t plus 1. And so we get y is equal to 1/2 ln of x plus 1. And so this logarithmic shape emerging, let me back up a little bit, makes all the sense in the world when we eliminate our variable. Okay, so that's the introduction to parametric equations. We're going to do a little bit of calculus with them in the next section, and then we're going to talk about polar coordinates, which are kind of also pretty cool.